All right then. Welcome to the next session in the main track of SODACON 2021 Day 2. We are now discussing Open Data Framework ODF for Cloud Native Container Storage. Is it so important? To discuss this, we have with us Sanal Kumar, Chief Architect and member of Technical Oversight Committee and the Architectural Workgroup Lead for SODA, and also the Chief Architect at Huawei Technologies. And we have with us Kiran Moa, Founder and Chief Architect at Maya Data. Over to you, Sanal.
Okay, thanks, Amit. Let me share the screen. You're able to see the screen, right?
Yes.
Okay, good to go. Okay, ODF for cloud native container storage. Is it so important? Okay, that's our topic today. So mainly we will discuss about cloud native container storage and these are same or not, and what's happening in the industry. We'll try to learn and see that what next in container storage. With me, Kiran Mova. Kiran, can you introduce yourself?
Yeah, sure. Thanks, Anil. Always great to be sharing the screen with you. You make it fun. Looking
Come
forward
on,
to this session, and I'm pretty sure you'll drag me over the
don't create expectations.
few minutes. Yeah, I think this session will be good. We are trying to put out all the different terminologies that are used there, and demystifying what they mean and how sort of is actually working towards benefiting the larger storage community. About me, I'm Kiran Moa. I work at Maya Data. I'm the co-founder and chief architect in terms of roles, and I'm also associated with sort of foundation as a talk member. I helped found and actually maintain the OpenEBS project. That's currently what I'm doing these days. All right,
Yeah,
back to Sunil. Yeah.
yeah, thanks, Kiran. Myself, Sanil, I'm part of SODA TOC and working with the community to bring out ODF. Let's get started. And oh, by the way, welcome to our session and good afternoon or good morning or good evening, wherever you are. Okay, let's get started. Okay, so yeah, this slide is kind of self-explanatory. What's happening in the industry? Fading boundaries. You can see a big globe, some servers, some laptop, and at the corner, I somehow put one mobile also. So it means that whether it is edge or cloud or on-premise, the boundaries are narrowing down. That means things are seamlessly connected. Initially, we started talking about edge computing, and today we are talking about edge cloud. And we started talking about cloud and then started talking about multi-cloud. Then today we are talking about hybrid cloud. So basically, things are getting connected, so boundaries are narrowing down. Why we say this, we will come to know in the subsequent slides. Okay, so we'll just see, we'll just start from our title, Cloud Native and Containers. Is it really important? Please note, the storage is not there in the slide. It is Cloud Native and Containers. And as you know, I think yesterday keynote and today keynote, you might have already seen some of the numbers which we have got from SODA Data and Storage Survey. I picked some of the key input from that survey with respect to containers. And if you see, most of the platform users are moving towards container-based environment. This is one of the key findings from that. And over the last 5 years, there has been a seamlessly rapid transition from VMs to containers. Maybe if you are in the cloud space, maybe VM to containers to micro containers to serverless, and this is the way things are moving. Let's restrict the discussion to containers for the sake of time and scope. Another key important point, I think today's keynote also in big letters, Steven showed that the Kubernetes deployments came as a top 3 platform deployments. So that is Kubernetes Cloud, hybrid Kubernetes, in the sense on-premise and cloud, and also to some extent edge, because K3s, QA and all these things are placing in that scope. And then Kubernetes on-premise or whatnot. So on-premise, cloud, and hybrid, so everywhere. So Kubernetes is getting deployed kind of everywhere. This is a finding from SODA Data and Storage Survey. What is the industry report says? We try to collect some of the industry report and try to understand what is the positioning of container. So the application container growth is more than 26%. It is just in 4-5 years time frame. And container as a service, this is becoming, the growth is very much high because the applications are deployed as service, and container as a service is also a solution. So in just 5 years time frame, it is growing like 35%. Now, these are some kind of research. What about the real deployment? So the last 2 points indicates it is not just notion. It is not. It is not just notional thought. It is real. The installed base of container instances is growing altogether 62%, and based on a CNCF survey, it says that 84% of respondents says that they are using real production. So cloud native and containers, no more a notional thinking. It is real. It's happening. Okay, that's what we wanted to try. Okay, container and cloud natives, it's important. So what? So how would container storage? Okay. See, as you know, any application deployment, if it is whatever way you deploy application, there are 3 important things: compute, network, storage. So as cloud native grow or container deployments are growing, so as container storage. The real use cases people are using, even in our survey, we found that people are using container storage for real use case deployments. How about the industry? Industry is moving more towards container-centric storage solution. If you see most of the vendors, I think subsequent slide we try to mention that most of the vendors are also bringing solutions based on container-centric solution using their existing boxes and some of the ecosystem solutions. And hybrid cloud data management for disaster recovery or data protection, those kind of things, it's becoming very, very important. The last point, that is where I talked about the vendors. STaaS, it is storage as a service. Now, going forward, we'll see container storage as a service. Now, this is becoming, if you just Google about most of the top storage vendors, the new products, whatever is coming, it is completely as a solution. So most of the people are moving into SaaS or STaaS, storage as a service, wherein their products include their hardware boxes and SDS kind of components, and more towards container based solutions. So it is becoming hybrid and vendor agnostic, because most of the vendors product, they are trying to support the third party as well. So vendor agnostic, and the direction is container storage as a service. Now, too many words. Container storage, cloud native, container storage as a service. Kiran, you have to provide some light on it because it is confusing. Is it same? Cloud native storage is same as container storage, same as CSI?
I think you also introduced like 2 new terms today, STaaS and CSTaaS. That's pretty cool. So I think like there are definitely some subtle differences between like each of these layers, and industry kind of uses these terms to define a category of storage that's fit for that particular time, or like the continuum in the growth of the storage. In the past, like if we go back, like software-defined storage was a term that was coined when virtualization was picking up, and there was like software-defined storage, software-defined networking, software-defined computing. Everything was software-defined, and it did have key aspects to that one, which was about it has to be API driven and auto provision. It primarily focused on that. But then when the cloud native came into picture, it extended the definition of the software defined storage into how do you actually build highly performant and like scalable systems, because this is the time when like Netflix, Amazons were like growing, and companies were actually developing the software, or like deploying the software directly on the cloud. The term cloud native really comes from there, where you're designing your applications to run in the cloud, and in essence you're basically getting like all the good things that software defined storage or like the software defined X introduced in terms of API driven auto provision to be more performant and scalable. Now, that was an era of virtualization and like cloud that we have seen, but now, like you kind of pointed out, Kubernetes is taking over, and it's pretty much available in all the data centers, all types of flavors. And it wouldn't be like an understatement to say that Kubernetes is the new Linux, right? And it's primarily driven by the adoption of containers and container-centric solutions that we are building. It's actually penetrating like not just the applications but also the storage platforms that we build. I think we have like a couple of slides on that. So once we start serving these container-centric applications, we need to have all the good features of container native storage. Plus, we need to adopt to the latest and the good practices that industry has put forward. For example, like APIs, which were like imperative in cloud native storage, now they have to be declarative, and they have to follow like the GitOps way of like doing things. It's not just auto provision anymore; it's also like auto healing. We were talking about scale in terms of the capacity and performance in terms of throughput and IOPS, but now containers have introduced this new notion of like the volume churn. The scale at which the volumes have to be provisioned and deleted could be like 1,000 times or tens of thousand times more than we are used to seeing in the cloud native or like even like the previous world. All these things, I think, like are fueled primarily by increasing the developer productivity, increasing the operational team's productivity, and also making sure like we get a better utilization of the hardware that we have, faster time to market on the better and good hardware that we get. In fact, like I think the Cortex is one project that was built, that's now part of the SODA ecosystem, that was built for this custom purpose. How do you actually take the greatest hardware that's getting built and push it to the market as soon as possible so the benefits could be like passed back to the users? So container storage is that category that is trying to enhance developer productivity, optimize the cost for vendors, and also like follow the principles that are being set forward in the current technological terms, or the best practices that architects follow.
So you mean storage for cloud native is cloud native storage? Is that what you're trying to say?
Yes. So the before
container storage is just one of them.
Exactly. So container storage can be considered as like it has all the aspects of container native storage. So container storage is container native storage, but container native storage alone with what was being developed like say 5 years ago.
So you deliberately told container native storage, or it is cloud native storage? One more term, I think we need to explain one more.
Yes, so it's cloud native storage. So container native storage is not cloud native storage, and we can call the new term as container native storage or container storage. Right.
Okay. So now this leads to one more question to answer, that we talked about container storage and container native storage. Now that is where the CSI container storage interface comes into play, right? So you have been working in Kubernetes, OpenEBS on CSI. So let's see the difference between these two also.
Yeah, I think so. A lot of misconception around like how do you transition from cloud native storage to container native storage or container storage? How do you actually do it? The shortest path is make sure like your pods are able to consume the volumes from what used to come from cloud volumes or cloud native storage. But then the interface to do that is basically CSI, but that's just not sufficient. CSI is just a specification that's going to help pods consume the storage. Whereas when we talk about container native storage or container storage, it's about implementing that spec by the storage vendors and also enhancing the capabilities of the storage layer with all the new things that we just introduced as part of container storage, which are like declarative API, auto healing, and ready to handle the volume churn that's going on. And one key aspect of
So
this
the
is
specification, the implementation of the specification is nothing but CSI drivers or CSI plugins, right? And based on
absolutely
CSI spec.
right. Yeah, another key aspect is like, we should be able to scale up as well as scale down. I think like in the past, like scaling down was a huge problem, but that should be solved as part of the container native storage or container storage.
Okay, I hope we covered cloud native storage, container native storage, or container storage, container storage interface. Interface is a paper, it's a specification, and then implement that. Probably you have CSA driver or CSA plugins which can work with the container platforms for a particular storage or a types of storage. Okay, so now we hope we just started. Okay, now we just before we go into what we have for container storage in ODF, we'll just try to understand ODF. Uh, SODA Open Data Framework, ODF is Open Data Framework. Our vision is to make a platform which can connect data anywhere. Okay, so anywhere in the sense you can have different kind of platforms, application platforms on the top, and a different kind of storage below. So how we can seamlessly connect? Because traditionally the storage boxes or storage solutions are either vendor locked or recently probably application locked. Say for example, it is completely CSI based or maybe OpenStack drives the protocols, something like that. Where ODF tries to unify across vendors, platforms, and domains, and like file, block, object. Always you debate that which is more important tomorrow, right? There are a lot of research happening. So how can we support all these across hybrid? Because we have been talking about hybrid and multi-cloud. So edge, on-premise, and cloud. How we can seamlessly connect all these platforms to storage, connecting data. This is where we want to. This is our dream. This is where we are taking step by step as our releases. Now, a little more deeper onto this, that some of the key points of open data framework is one is it's completely open source, so there is absolutely no lock-in, and it's a community-driven development, and it connects data silos. Why data silos? Because whatever is proprietary or localized kind of implementations, we just try to remove that connects them. Then it is extensible because we do not want to create something which is monolithic, because we want to use ecosystem projects and solutions available, which can be seamlessly can be connected to ODF. That is a way we can build bigger solutions. You will see a glimpse of that in the subsequent slides. And some highlights is that we would like to have some kind of standardization across application and vendors, build an ecosystem of hardware, software, solutions, and services. That is where you can see 20, 30 partners already, and we are looking for more stronger partners like even the storage vendors. And then in future, certify that this is ODF certified solution which can work across the board. On the right hand side, you can see different projects. So you can see something called the SODA plugin. Why this is SODA plugin? We use this SODA plugin to connect different platforms to our platform. And then you have API, a doc is where you have all the drivers, and the controller is kind of a bookkeeping, and then the multi-cloud piece where you can connect to any different cloud vendors. You can see some list here. It is more than that we already support in the Java release. We also have some kind of a monitoring solution across the heterogeneous storage, which we call it as Delphin. Delphin is another name of dolphin. Everywhere you go SODA, you can see multiple dolphins because dolphins are smart, like our community. Okay, let's go ahead. Okay, now let's focus on what is specially available for CSI or the container storage part in ODF. So ODF natively we support Kubernetes, and now we talked about SODA plugin. Similarly, to connect Kubernetes, we have SODA CSI plugin, because most of the storage, the standard, like Kiran was telling, CSI is a specification. You implement that, any of the container platform can be connected to your storage. So we create a SODA CSI plugin. What is the speciality of this? Usually, any of the storages, if you want to connect separate CSI plugins, you will write. But in our case, you have only one SODA CSI plugin which can be connected to any storage below. We also have something recently developed called CSI Plug and Play. In the sense, you use SODA CSI Plug and Play and use any of the CSI drivers which can work. Not only one CSI at the same time, more than one CSI at the same time can also work in the latest Java release. On top of this, the last one, the hybrid data management for cloud native. Recently, we started experimenting on how we can bring effective data management within ODF for Kubernetes. That's when we have seen many products like Velero and things like that, open source solutions like Rustic. So we already have a solution on data protection based on Velero, which is already released in the Java release. Now, I think because of the time, I will run fast. So this left-hand side diagram, don't worry too much, because it is just a copied diagram from CSI. It's a completely CSI only. But the blue portions are the sidecars of CSI, where usually that will be written for specific CSI plugin. But in our case, we reuse that part. It is SODA attacher or SODA provisioner. All these things are reused components. Along with that, in the last release, on the right hand side, you can see operators. Instead of operators, we have something called SODA syncer. It is specifically right now working for the data protection part, but it can be used for monitoring and other kind of features, bringing in that. So on the left hand side, this is exactly the CSI plugin architecture. On the right hand side, we envision that we can add these kind of features outside CSI, so that with CSI we can give much more capability on data management, data monitoring, provisioning, DR kind of solutions across on-premise and cloud, and also edge. This is the idea. Okay, so we move on. Now, it's not only SODA thinking about container storage. We have already seen the industry, most of the vendors, organizations are looking into this. And we also have got friends. I think Anvith asked last time and nobody got 100 USD, and I'm going to get it. So Linstore, OpenEBS, Senko, Cortex. And this is the answer. 4 Echo projects joined SODA recently. And out of this, all these projects, one or the other way, it is actually related to the hybrid cloud or container based solution. Say, for example, block storage management for containers, Linstore focuses on that. And OpenEBS, we are going to see it in detail. Basically, Kubernetes storage simplified is the caption, the details is suspense. Kiran will take it forward. Zenko is mainly on the object store on multi-cloud, and Cortex optimized object store. As soon as you hear Cortex from Seagate, you may not even think that this could work with all these things. I have already seen a solution, you can Google that, Linstore, Kubernetes, Cortex. So Cortex works on resilience, Linstore works on that data replication part, and Kubernetes on the container deployment orchestration part. It's a nice solution. So that is the way the solutions are getting built. It is not in isolation, it is in together, collaborative. So we are actually exploring with this Echo projects how we can build solutions. So one of that we will listen from Kiran.
Thanks, Anil. So just quickly running through, I think like how any of these storage projects, container storage projects, fit into the overall diagram. This is actually a framework that CNC have developed as part of the storage white paper that was published and is also getting updated continuously. It's been around for some time now. So any stateful workload consumes the storage from, there's a specific data path you can actually consume via block storage, file systems, or object storage there. In case of OpenEBS, we also support block storage mainly, and the data layer writes it to external storage systems. Now, how does the volume provisioning and all happen? That's basically with the container orchestrators working via CSI, talking to the control plane of any storage vendor. In this case, I'm just taking an example of OpenEBS, and then that's just the single part of the whole equation about provisioning the volumes. There are a lot of things that we need to work out in terms of providing the complete lifecycle management, and that is where SODA comes in as part of the framework and tools part, right? So within a couple of things about OpenEBS. OpenEBS is developed natively in Kubernetes for managing the storage that's available within the nodes of Kubernetes, and it can basically work with any storage system. It could actually work with like LinStore replicated volumes, or it could actually even work with cloud volumes or other storage vendors. We focus primarily on simplicity and the performance aspects, and then ability to give a custom data engine for each of the workloads. Sometimes the engines don't need replication at the storage layer, so we try to provide like local storage for them as well. Next slide, please. So this is a typical workflow on what are all the various things that happen to make the container storage work. In this case, the SODA along with if SODA is not in the customer's data center, there are definitely tools and frameworks that SODA is developing that customers are building in-house that are helping the node preparation or the cluster lifecycle related kind of systems, which is about like setting up the overall monitoring or setting up devices and creating nodes with like required storage and creating Kubernetes clusters out of it. I think we will see in the future some projects that are being developed under the CNCF umbrella come into the SODA ecosystem as well. Like for example, Crossplane is one of them, or a few other cluster lifecycle management projects, right? And from there, we kind of look into the platform SRE operations where we need a standardized way of defining the storage classes. This is where again SODA comes in and helps with a unified CSI driver or like the CSI plug and play, where the nitty-gritties of the underlying storage or like the features are abstracted into something that's standardized. This will in turn help the stateful workload operators to use a standard set of storage classes instead of every time trying to refine their operators with what in the storage provides. Using SODA kind of helps to really build a hybrid storage layer, abstracting away the details of the underlying storage, right? And then while the storage can focus primarily on taking the volume request, servicing the volumes, and actually doing the data operations, right? And then again, like the fifth, as part of the fifth point, like the control comes back to SODA framework or like the tools where we can continuously monitor and perform some lifecycle operations on the volumes. If you go to the next slide, I kind of list down like the various operations that we have to do in these three stages. So in terms of infra provisioning, there is actually a trend in terms of containers using smaller volumes, which basically helps even like on-premise for customers to build a rack scale data center kind of in pattern, which typically clouds used to build. Now that can be done by other enterprise customers on-premise as well. So for that, like you need to kind of look at all the storage that's available in the data centers via JBots or via like different storage systems as individual pool of devices that can be given to like different set of worker nodes. That's an area that we can kind of really work out with the infra provisioning layer that we're working in SODA. Then in terms of volume provisioning, this is where like the CSI in fact is lacking in terms of like the features it can provide, because it needs to go as a standards body and like it needs to really work with all the container orchestrations. Here the storage vendors are a few steps ahead in terms of like providing the features that the workloads need. Now while playing this catch up, if you can just go to the next slide, while playing the catch up, it kind of becomes hard to maintain like that upgrade compatibility and all that with the CSI driver. So SODA with its CSI plugin can abstract those difficulties or like the missing pieces from the CSI, it can actually plug those in. So I kind of call this diagram as SODA takes in the interfaces that Kubernetes provides as A, and then enhances that with like additional information that is required as A plus, and passes it to the control plane. So the features that are available in the storage can be really leveraged for the stateful workloads. So what are those features that we're talking about? Like if we just go to the next slide. Let's say, like, as part of the container centric approaches to designing the platforms, we have developed a stateful workload that actually replicates its data, and it wants to serve its customers in a way that it's fault tolerant across, like, a complete rack filing, or sometimes, like, the entire floor, like, getting some issues. So in those cases, like, the Kubernetes actually provides a very nice primitives to stateful sets where you can deploy multiple replicas and provide anti-affinity or affinity kind of roles with respect to the zones. But now when the volumes are getting provisioned, that information is lost at the CSI layer. It does not get percolated down into the CSI or like to the storage vendor. This is where SODA CSI can come in and help get some additional information about like the way the applications are getting deployed in the Kubernetes cluster, so they can be scheduled in a better way on the storage layer. Thanks, Anil. You can take it back, I think, in the interest of time.
Okay. Yeah, in the interest of time, we'll just close it. So what we discuss is that one point is that storage as a service, data protection monitoring. These are some of the areas quickly we could look into in ODF. And industry is moving something like storage vendors versus cloud vendors, because cloud vendors are providing on-premise, storage vendors are providing cloud solutions like that, block versus file versus object, and open solution versus vendor locked-in, and storage box versus storage ecosystem. This is where we are, the industry is moving, and we feel that ODF is in the right direction. And one more good thing is, especially for developers or whoever is working in this area, is that high demand, lack of maturity. So there's a huge scope of development, new innovations, and lack of tools. So this is a great opportunity for us, all of us, developers. And if you want to bootstrap, these are some of the quick links about very basic concepts, Kubernetes, CSA introduction, understanding very basics of what is storage, and OpenEBS introduction. This is enough to bootstrap, and if not enough, you can Google more, or you can join SODA Slack, that where we can discuss and we can also work together towards this. That's all from our side. Thank you so much. Please.
Thank you. Am I audible now?
Yes, Sanit.
Okay. So I'm really sorry, but we are way over time. We were actually good on time, but I think the session was quite interesting. So we went on carrying on, but right now we are really out of time and we have to move to the next session. But having said that, I have one more voucher to give away. So if you are attending this session, then you are one of the lucky few. Let me just ask this question. I'm going to put it in the and this is something which you should know if you've been attending from yesterday. So as before, I'll be posting the question in the Q&A box, but you have to answer in the chat, because I will be checking only the chats for the reply. The first complete answer wins an Amazon voucher worth 100 USD. So the question is very simple, very simple. It's there on the beginning of the reception booth itself. Okay. So who are the platinum sponsors for SODACON 2021? Who are the platinum sponsors for SODACON 2021? I want all of them. I want all of them in one answer. Don't break up the answer in multiple messages. Then you will give away the prize to somebody else. Let's see who is fastest finger first. I will give it to typos, not a problem, but make sure you get all of them. Let's see who's the first to message in chat, message in chat. Who are the platinum sponsors for SODACON 2021? I keep saying chat. I don't see any messages. People are going to the reception, coming back. Coca-Cola, Abhishek says Coca-Cola. That's a good answer considering it's soda, but no. Veena, you says Intel and IBM. Okay. Like I said, let me get a complete answer. I will have Veena, you as my first answer, but let's see if anybody else can get. All right, so we have this Fujifilm, IBM, Intel, Toyota, Huawei. Rohit R. Sekar, congratulations. Rohit R. Sekar, congratulations. You are our winner for the next voucher worth $100. Rohit, please do send me a direct message with your email ID. And oh, we've got some more answers afterwards. But fastest finger first. Veena, I said complete answer. I know you wrote two, but still, Rohit was good at getting all of them. So congratulations, Rohit. The correct answer is, in fact, Fujifilm, Intel, IBM, Huawei, and Toyota. With that, we come to this end of this session. We will now move to the next session, and that is a demonstration of the ODF features for container storage. Please join us in the next session. Thank you.